Welcome to a video tour of Google's first container-based data center. There are slots for over 45,000 servers in the 45 containers housed inside. The data center itself went into service in 2005 and supports 10 megawatts of IT equipment load. It has a trailing 12-month average power utilization effectiveness value of 1.25. We start with the plan view and focus in on the equipment yard we will be visiting. Here we see the cooling towers, the power distribution centers, and the generator farm. Our first action shot shows water flowing down the cooling tower fill. The plant itself is designed to maximize waterside economization through a combination of elevated process water temperatures, low approach temperature plate and frame heat exchangers, and a chiller bypass path. As we swing over to the electrical yard, we see a medium to low voltage distribution center. The transformer itself is not exotic, but boasts a better than 99.5% efficiency, as evidenced by the relatively small cooling radiators attached to it. As part of the distribution center, the transfer switches serve to connect the generators seen here. Eventually, the output of the distribution center is run into the building through these low voltage cables. Stepping inside the building, we again pick up the low voltage distribution lines. Cable routing takes place in these standard trays that eventually head off for connection to the container switch panels. We now step into the cooling plant. As we pull back, we get an overall view of the web of piping required to connect all the equipment together. As the water returns from the cooling towers, a portion of it is taken off and directed through a side stream filtration system before being returned to the loop. Continuing on, we trace the piping down to the array of pumps where we see that we experience our share of leaks. Of course, when we talk about cooling plant efficiency, the chiller uses the most power and is therefore our biggest target. And an important part of reducing chiller hours is the use of plate and frame heat exchangers with their low approach temperature characteristics. We conclude the tour of the plant with a shot of the thermal storage tanks and the distribution piping that carry the water to the containers. The hangar tour starts with a shot of the bridge crane used to move the containers. As we pull back, we get a view of the single-story side, which is more clearly seen from a vantage point on the mezzanine. There are 15 containers on the single-story side and 30 on the opposing 2 stories. Amongst the safety considerations in using containers, we include emergency exit stairs and egress pathways as required by code at the tail end of the units. This final view gives us an idea of the scale of the hangar bay. In this segment, we follow one of our technicians to the container, where he is dispatched to perform a server replacement. Here, we see him making his way on his Google-provided personal transportation device. He must first verify the machine location. As you see here, each tray is outfitted with onboard UPS running at greater than 99.5% efficiency. Once inside, our technician removes the tray blank and installs the repaired server tray. The cold aisle inside the container is maintained at approximately 27 C or 81 degrees Fahrenheit, enabled by attention to good airflow management. Here we show our idea of Google Nightlife. Another technician is entering the container to inspect the underfloor area. As he lifts the floor grate, we get a view of the flex hoses, power conduit, and fans used for cooling. In fact, there are many more system details designed into the container as shown in this isometric cutaway, and this cross-section view detailing the tightly controlled airflow path. As we step out once more into the vestibule area, we see the hookups bringing water into the container. On the other side, we find the electrical switch panel. And inside the panel, we trace the cable inputs into the breaker section and get to see some of the circuit transformers used in gathering our PUE measurements. All in all, there are many additional support systems required to satisfy the safety and occupancy requirements of the container, including emergency off buttons, fresh air supply, fire detection, fire suppression, smoke dampers, and much, much more. We end our video tour with another view of the hangar and a summary of the best practices incorporated into this data center. Recapping, on the electrical side, we saw the use of high-efficiency transformers and UPSs, along with the necessary circuit transformers for accurate PUE measurements. On the cooling side, we touched on many aspects designed to allow raising of the temperature inside the data center and the associated reduction in chiller usage hours. One last thing to note, the best practices we presented here are the main reason we've been able to achieve our PUE results and can be implemented in most data centers today. Thanks for watching.